Our topic for today is Biot-Savart's law. Biot-Savart's law. What is it? It is basically magnetic field due to a current carrying element. We had seen, if let's say this is a conductor. If this is a conductor and we had a magnetic field in which this conductor was placed, and this conductor was carrying a current I, that is, charges were moving, then we had seen what is the force experienced by this conductor due to that magnetic field. Now here what is difference in this Biot-Savart law? It is that if this is a conductor, let's say, and it is carrying a current I, if we take a small element that has length dl, this element, at a distance r from it, let's say this is distance r, at a distance r from it, what will be the magnetic field? Magnetic field due to this current carrying conductor. Clear? We don't have an existing magnetic field. We are understanding, we are examining what is the magnetic field due to this current carrying conductor. So if we take a small element dl, what will be the magnetic field due to this current element at a distance r from it? So it was found that, let this magnetic field be dB. So it was found that it is proportional to the current I. It was found that it is proportional to this small element, length of this element dl. It was found that it is proportional to inversely proportional to r square, like Coulomb's law. And it is found that the direction of the magnetic field is perpendicular to the plane containing this element and this point. That is, you can say this is like this dl cross r in vector. This is, what does it signifies? Dl cross r will be perpendicular to this and this, the direction of this and this. So finally, if you add them all, what you get is, since you are using dl cross r in the denominator, you will have r cube. So it was found that the magnetic field due to current carrying element is given as I dl cross r. Since we have used r, so this will be r cube. Okay. Now, since we are using proportional sign, you know how to remove it, how to make it an equation by putting a proportionality constant k. This constant has been found to be equal to mu 0 by 4 pi, where what is mu 0? Mu 0 is the permeability of the medium in and what is the medium? Vacuum. So it is called permeability of vacuum. Okay, and its value is equal to 4 pi into 10 to the power minus 7. What will be the unit? This is in Tesla. This is, see, r square, so meter square, this is meter, so meter, so Tesla meter, and when this goes down, this will be ampere. Okay, so this is Tesla meter per ampere. This is the unit of permeability. So this is called Biot-Savart's law. Okay, dB is mu 0 by 4 pi I dl cross r by r cube, but where this is mu 0 is permeability of vacuum given as 4 pi 10 to the minus 7. So it's very easy, you just have to put 10 to the power minus 7 and then these values. Okay, now if the angle between dl and r, this angle, if this angle is theta, you know this is what? This will come to mu 0 by 4 pi. This will be dl r sine theta. So I am crossing this r. So this will be I dl sine theta by r square. So the magnitude is this. Okay. Now the difference here is, the difference from Coulomb's law is that in Coulomb's law, the charge was static. Here the charge is moving. This is due to moving charge. Secondly, this is a vector. dl is a vector, whereas there in Coulomb's law it was a scalar quantity. Okay. Another difference was, if this was plus q and we were finding electric field at this point P, it was not dependent on any angle, that whether it is at this point or this point or at this point. It was dependent only on the distance of that point from that charge. But here we have angle, that is the direction of the current element with the position vector of the magnetic field, okay, or the point at which we have to find the magnetic field. So these are some differences. This is Biot-Savart law. So let's see a very small example to clarify this, how to compute this expression. Let's see a very small example. We have a current element, its length is dx, okay, and the direction of current is this. Perpendicular to this, what will be the magnetic field at a distance 0.5 meters? Let this be point B, okay. I'm not giving point or cross, we'll see what is the direction, or we can see the direction here only. You know that this is what we get dl cross r. So dl is this and r is this, so dl cross r means anti-clockwise, so this is out of this wall, therefore this will be point, not into the wall, out of the wall. So you understand the direction of this magnetic field. Again I'm saying, see, dB is mu 0 by 4 pi dl cross r by r cube. Now dl cross r means dl is this, r is this, so dl cross r means by screw rule out of the wall. So the direction is, the arrow will be pointing towards this, so this is point. So this is our direction, and what will be the magnitude? See, this will come to dl r sin theta. This becomes r square sin theta. Theta is 90. See, 90, it is perpendicular to this. So it is simply dl cross nothing, I cross dl by r square. So mu 0 by 4 pi, it is 10 to the power minus 7. I is 10. dl, what is the length of this current element? Okay, I forgot to write it. Dx is 1 centimeter. So this is 1 centimeter. So in meters, it will be dl is 1 centimeter. So 10 to the power minus 2 meters by r square. R is 0.5. So half square. So 1 by 4. So what do we get? 4 cross, this is 10 to the power minus 1. So this will be 10 to the power minus 8 Tesla. So the magnitude of the magnetic field is 4 into 10 to the power minus 8 Tesla, and its direction is out of the wall. Clear? Now let's see, if we have a circular loop like this, okay, this is a circular loop and this is the center of it, and we want to know what is the magnetic field due to this current carrying circular loop. A current, let's say I, is moving in this circular loop, then what is the magnetic field at this point? Clear? Let this point be P or something. This is our question. So what we do, we take a small element here, dl, which has this direction. This is your dl. The direction is this. Don't confuse with that this is your dl. dl is a small quantity here only. This one only. Its direction is this. Just to tell you the direction. Now let's join it to the origin, not origin, center, and let's here. Okay. Now this is your length r. Distance between this point and this current element. I'm talking of current element only. Our topic is magnetic field due to a current carrying circular loop. Okay. So what will be the magnetic field here? dB at this point. It will be, from Biot-Savart's law, it is mu 0 by 4 pi. I is the current. It will be dl cross r by r cube. This what will be the direction? Now let's see the direction. See, this is this is direction here, and this is r. dl cross r. So it will be proportional to this and this. That is, it will be out of this. This is this and this is this. See, try to understand. It is this and it is this. So perpendicular to these two directions, this. So we'll have magnetic field. The direction of magnetic field will be like this. Okay, perpendicular to this and this. That is dl cross r. So now, if let's say this is theta. Let's say this is theta. So we have two components. This is dB sin theta and this is dB cos theta. This you understand? What will happen? This component, dB sin theta component, this magnetic field dB sin theta due to this will cancel out due to magnetic field at this point. This will be in this direction. So the sine theta component will cancel out. Each and every opposite part on the circle will cancel it out. So we'll have dB cos theta component only. So what we need to do is we'll calculate this whole circle, the magnetic field due to the whole circle in this direction only. Now this is theta. So this will be 90 minus theta. Okay, so this is theta, this is 90 minus theta. This is 90 minus theta, so this will be theta. Okay, let the radius of this circle be r, and let this be, we have used small r, so let this be x distance from here. Okay, now let's come to our, what we know, that we'll have dB cos theta component only. This we know. So magnetic field will be, what you can write, it will be mu 0 by 4 pi dl r by r square. So we can simply write I dl by r square. Okay, I dl by r square, because we know what is the direction, and into cos theta. What is cos theta? Cos theta is, see, this by this, r by r. So this is r by r cube, and let's see what is r. See, we must understand what is r. R is under root r square plus x square. So what do we get? We get mu 0 by 4 pi I into dl by, this will be dB. So I dl r, okay, by r cube, and r cube will be r square plus x square. This is half and cube, so 3 by 2. Okay, now if we take, this is clear. What we'll do, we'll take summation or integration throughout the loop. So B, complete magnetic field, will be summation of dB throughout this loop, and these components are free of this. Only dl will have to take summation of dl only. So if you take summation of dl, this will be the circumference of this circle. So this will be mu 0 by 4 pi I r dl. So dl is, when you take summation of dl, it will be 2 pi r, the circumference. So this will be 2 pi r square I by r square plus x square 3 by 2. Now this comes to mu 0, 2 pi cancels this as 2. So this is I r square by 2 r square plus x square 3 by 2. And the direction is this direction. That is, if you have origin, if you take this as origin and this x direction, this as y direction, so the direction is in x direction. So you can write I cap for this. Okay, so this is the value of magnetic field due to a current carrying loop, circular loop. An interesting figure is, what will be the magnetic field at the center of this loop? So at the center, x is equal to 0. So if you put x as 0, what you get? This is r cube. So B will be, see, this is r cube. So you will get mu 0 I r square and r cube cancels. So this is by 2r. Clear? At center, I am writing O. So at the center, the magnetic field will be this value, and it will, the direction will be this only. Okay. So from here, let's understand how to find the direction of the magnetic field. It is your right hand thumb rule only. See, if the current is moving in this direction, so what you have to do, you have to, let's say this is the circular loop, this is the circular loop, like this, not, we are not talking about this. So wrap your fingers in this direction, in the direction of the current, and your thumb will point to the magnetic field. That is, if this is circle like this, current is moving like this, then this is this direction. But if the current is moving like this, it is inside it. So this is right hand thumb rule, you should know this. So let's find out what will be the magnetic field due to these two, this is 1, this is 2, these two current carrying loops. These are half semicircles. Current is like this. Because this is circle, you know, due to a circle, the magnetic field due to a circle at its center is, we just found out, it was mu 0 I by 2r. So if this is r, your magnitude of your magnetic field is this. Clear? Due to whole circle. But when we are talking of half circle, semicircle, so this will half of this, so this will be this by 4r. This is okay. So magnetic field, magnitude of magnetic field due to these two will be this. But what about direction? See, I told you right hand thumb rule. Loop, the current is in this direction. So you'll have to wrap like this. Where is the thumb pointing? Into it. So the magnetic field will be this, into this. So into, cross. What about this? See, wrap like this. This is out of this. So this is this. I think you must have understood this. Let's understand one more example. We have a coil. The number of winding, the number of turns, if a wire is taken and it's wound like this again and again, so let that number of turns be n, okay, and the conductor carries a current I, that is I current is flowing, this is n number of times. The question is, what will be the magnetic field at its center? Now you know that magnetic field at the center of a current carrying circular loop is mu 0 I by 2r, and its direction you know. If you have n number of turns, you can say for first turn it is this, for second term we'll have again this, for third term up to n number of times, n times. So this will simply be mu 0 ni by 2r. And what will be the direction? You know it very well. If it is like this, if the direction of current is this, then this, you wrap like this, it is into it. But if the direction is not this but this, then it is out of this. So for this it is this, the direction is this, and the value of the magnitude of the magnetic field is this. Clear?